If you like our content, please like, subscribe, and click the notification bell to get alerts when we introduce new videos.
So in this module, we're now going to look at other options for plugins to use within the IoT controller. And this particular plugin we're going to configure is for what we call the controller data stream. So this is a new mechanism that allows you to have the IoT controller provide you with status and event updates automatically without having to use the API to poll or to query the controller and find out information about device status. In our network, the key thing is that devices on the edge, our IoT sensors, need to provide information from the sensor through the IoT access point, the IoT gateway, through the network and into the IoT controller. Today we use a secure encrypted Mqtt connection between the IoT access point and the IoT controller, but that is used for management. So when you want to find out what's going on within the network or with a device that's connected down on the edge, we use the API, the RUCKUS API, to query the controller, which will then send a query message to the sensor and respond back with any event changes or the current status of that device. This mechanism works very well, but as you get to a larger network and you want to be more efficient with your network traffic and your Zigbee communications, it's much more efficient to have the sensors, when an event changes or a state changes, push that event change automatically up to the controller and then from the controller straight into your application. So you no longer end up with having to query or find out what's going on within the controller through a polling process. You can now get an update only when device changes or state changes happen. So as we look at how this might be configured, we are going to set up a plugin within the IoT controller for the controller data stream. We're going to configure the attributes to forward from the controller to a third-party server, which is going to be running an Mqtt broker. So in this environment, we're going to be using a Mosquito agent that is running on a standard Linux environment to take all of the messages published from the IoT controller into the broker. And then in our rules engine, our application, or inside a solution that we've developed, we can subscribe to those events and have the data forwarded directly from the broker into the rules engine. So this allows us to have a seamless connection through a third-party agent, and we get automatic updates of status information, but also event changes within the IoT controller. So again, within our IoT controller here, you can see we've configured the system and we have a basic setup operational. So you can see the overall dashboard. We have two access points connected. One of them is online and approved, the other one is not. But what we've done differently in this setup is we've configured one of the access points as a Zigbee access point, and we've onboarded a device onto that. So as we look at our access point, you'll see we have our H510 AP that we are now running in Zigbee mode. So we've reconfigured the i100 radio from BLE to Zigbee mode, and we've enabled the device. And then on top of that, we've scanned and onboarded a sensor, which is covered in a previous module. So our devices wise, we now actually have a Samsung door sensor, which is a Zigbee sensor, has already been onboarded into the IoT controller and is operational. So we can see the capabilities of that sensor. It's a contact switch and its current zone state, and it's also measuring its battery level, and some temperature and humidity levels are also available through this sensor. So the device is operational and working within the IoT controller. So what we can now do is add in our controller data stream. So as I mentioned, the controller data stream is currently disabled. So we go to our admin and we go to our plugins, and within our plugins now we can activate the plugin that we're interested in. So we can do the drop down and select the controller data stream. So this is going to set up the agent within the IoT controller to forward data to our broker and then to our rules engine. So we can activate that now. So here now we have the setup and configuration. So what we need to do is to enter in the IP address of our Mqtt broker. Now that is running on a Linux Ubuntu machine as an agent, and the machine is on 192.168.111.120. We also need to define the Mqtt broker port. Now for standard MQTT that would be 1883, but obviously you could choose a different one if you want to. And then we need to define where we want to publish our data to. So in this particular case, we're going to publish to a topic called topic, and that is going to be push an update of all of our devices on the IoT controller, and that will push an update every 10 seconds. So instead of having to poll the devices, you can actually now have a periodic update. Every 10 seconds, the controller will tell your application what is going on with all of the devices on the IoT controller, their current state, current signal level, battery level, etc. Full update every 10 seconds will be published to your application. Now, one of the other things we want though is we want to see if there is an event change that happens in real time. So rather than having to wait 10 seconds to be told that a door has opened or closed, we can actually have the IoT controller now push us an update immediately. So what we can do is we can turn on device reporting, and we can type in a new endpoint. So we're going to push to report. So we're going to have two endpoints now that we're pushing to at an MQTT level, topics, one for just generic updates every 10 seconds, and then one when there's something urgent that happens that we ought to know about. So we can hit apply and enable that. Okay, so we know that our plugin has now been enabled, so we can again go back to our dashboard, and we can see that the plugin has been enabled because it's saying CDS. So that completes our configuration at the controller side and the MQTT push and controller data stream. So now that we've configured our IoT controller data stream, we can actually double check that it's working by going to our Mosquito broker. So if we go to our our Ubuntu machine, we can actually take a look and see what's going on. So this is our 192.168.111.120 machine, and you can see we have a load of services running on here. But the key thing is that on this machine, we can actually now take a look at the Mosquito MQTT broker's log file. So if we take a look at what's going on within that file, what you'll see are push and event requests coming in. So you can see that the 111.14, which is our IoT controller, has created a new session with the Mosquito broker, and you'll see that they are coming in regularly. So there are updates coming in from the IoT controller into the Mosquito broker regularly that we're able to see, monitor, and keep track of within the log file. Okay, so now we're ready to go and actually look at what's going on within our application. So our controller data stream is now pushing and publishing both updates every 10 seconds, but also any event changes from the IoT controller sensors all the way out to the application. So very much like we did with the other plugins, we can now create a very simple flow to receive that data and then process it. So the first thing we need to do is we need to set up an MQTT in node. So that is going to connect to our third-party MQTT broker, and then we can also add in another debug node so that we can view the data coming out. So the first thing we need to do is make a connection. So we connect to our MQTT broker. So we have our IP address of 192.168.111.120. The port number we're using, so we're going to use port 1883. If we were using a secure connection, we could also enable that. And we're just going to use default client because we're not running authentication or validation of users at this time. So once we've done that, we can then enter the topic that we want to connect to. So our default topic that we want to use is topic. So this is our update message that comes out every 10 seconds. And the output we need to change to a parse JSON structure. So we can do it afterwards, but it's easier just to have the node function do it now. So that will then connect to our broker, and anything that is published by the IoT gateway or the IoT connector will be published and forwarded into the rules engine for us to then view. So we'll connect that to here. We will look at the entire object, and we can go ahead and now deploy that. Every 10 seconds, the IoT controller will make a publish, and we will get that update. So there's the publish command that's come in from the IoT controller. So we can see that it was sent to a /topic, which was the one we set up for our status updates. And then in here we have the payload, and you'll see that we actually have a breakdown of each of the devices on the IoT controller. So there are two devices on the controller. One was a vape sensor and one was a door sensor. and you can see now that information about those devices. So the second device is our door sensor, our contact sensor, and the first device you can see here. So basically we have all the information that we need about that sensor and the information that was sent about it. So we have all of the cluster information, the device type, the LQI and RSSI, and if we look through here and we know our Zigbee clusters, we know 500 is our IAS zone cluster, and we can now go in and take a look at the zone status and the value. So we can see the door is currently closed. So very quickly now we're getting an update without having to use the API of what the status of that device is. And again, we can use this to get updated every 10 seconds. So if we were just looking for a device kind of periodic status, we could use that. But the downside to that would be if somebody opened and closed the door in less than 10 seconds and they just happened to time it right, you would miss that event change. So what we can do is we can take this now and actually use the other option, which is the Mqtt push event, and we can now subscribe to the other report that is being published by the IoT controller, and now we can deploy that event. And what we'll now see is if I now open the door sensor, and that will trigger an event immediately, and it comes into this flow because it's an event state change. So it comes into our report flow, and again, now if we go in, we can view the information specifically. So we now know the cluster ID, the endpoint ID, the attribute ID, and the value that has been reported. So because I opened the door, the state of bit 1 changed from 0 to 1. So immediately we see the state change from 0 to 1. And if I close the door sensor now, you'll see we get another immediate notification. And again, the payload has changed to a state of 0. So now, very simply, we're able to get status updates and information from any device on the IoT controller. But in addition to just looking at the data, this is not really very user friendly, and it requires us to actually now go in and figure out what these all actually mean. So what we can do is, by taking this one step further now and using a combination of the Mqtt push and the controller data stream along with the API, we're actually now able to make a far more complex and interesting application. So here we have an example where our topics are going to come in here, and we'll take the information coming in from the controller data stream every 10 seconds, and we will then use the API to go back to the controller and get more information about that device. So when a device is detected, we can query the controller and we can say, okay, who's the manufacturer? What are the capabilities of this device? If it's an IAS device, is it a remote control? Is it a contact? Is it a flood sensor? We're able to get all of that information and build a local database of the capabilities of every single device on the controller. Then when the message actually comes in on our report tab, in other words, somebody triggers that event, we're able to then look at that device, look at the information that's coming in and say, well, this is from cluster 500, so it's an IAS zone, it's an attribute ID with a class of this, therefore it's a door sensor. And we're able to then very simply within a very small amount of functions, able to actually turn all of those cluster endpoint attribute IDs into user-friendly data. So again, we'll do a similar kind of thing. We'll look at the data, and we will take a look at the incoming raw data, and then what we actually have as the device is deployed and the nodes are decoded. So we have our incoming event. So if I open the door, we can see we have our report that comes in. So this is the topic. So this is the original message that we received from the IoT controller. You can see with the value, the cluster attribute and endpoint ID. What we're able to do though is we're able to decode all of that data, and we're able to now actually convert it into something useful. So we get the device's name, we get the device type, we figure out that it's a contact switch, the value, and because we're able to determine that it's a contact switch, we're able to say true or false depending on whether or not the door is open or closed. So again, now if I close the door, we can get two notifications, one on the message and then one output. So we're getting a true and false depending on whether or not the door is open or closed, all just by some very, very simple code that is able to use a combination of the Mqtt push and the API to gather information and build a model of what that device is. And we can then scale this up now to support any number of devices or any different types or classes and add those into the system very easily.